answer, otherwise I shall pick a number there. Yes, roll number 12. Tell me what's the operating system. Define it. Okay, roll number 12 isn't there. Roll number 32. Am I audible? So it's a software which acts as an interface between the user and the computer hardware. Right, Satvik? See, it's a one-to-one communication, so you need not make use of the chat box. You can unmute yourself and tell me the answers. Okay, so it's a interface between hardware and the user, right? So what are the various functions that an operating system is supposed to perform?
Scheduling tasks.
Scheduling tasks. What sort of scheduling?
Like when the CPU should process the tasks and all that.
Yeah, when the CPU should process the task. So you mean to say that operating system is responsible for scheduling the CPU between the processes? Apart from it, anything anybody would like to add? There are several functions that an operating system performs. Quickly elaborate.
System management.
Execution.
Pardon?
System management.
It is responsible for system management. So what is the meaning of system management? What do you mean by system management? It's a very huge term.
Input output operations.
Input output operations. Okay.
Execute and provide the services.
What services? Okay. So let us begin. So what is an operating system? Now, by seeing this diagram, can you realize what exactly are the functions that an operating system is offering us? We call the operating system to be the resource manager, right? So it takes the form of a set of software routines that allow the users and the application programmers to access the system resources, right? So the system resources can either be hardware resources or it can also be the software resources, right? When I say hardware resources, it is operating system is responsible for allocating and deallocating the CPUs, right? The input output devices like memories, disk drives, and printers, right? So all these resources are to be properly allocated to the process that is running. So it is the responsibility of the operating system, right? So similarly, operating system is also responsible for proper handling of the system software as well as the application softwares, right? So you people might have already heard of inter-process communication, right? So can you people define me what is a process? Or what exactly is the difference between a program and a process? So program is just an passive entity, but when you allocate a CPU to it and it starts execution, then it becomes a process, right? So we call process to be an active entity, correct? So then there are various different services that the operating system is offering the you which the operating system offers to the user. So for example, an operating system ensures safe access to printer by allowing only one application program to send the data directly to the printer in case if you have multiple requests from different users for accessing a printer, right? So similarly, an operating system also encourages efficient use of CPU by suspending the programs that are waiting for an IO activity to be completed to make way for programs that can use CPUs more productively. Right? I guess you people have studied IO burst cycles, CPU burst cycles, right? In the operating system. Correct. So if a particular process moves to a state wherein it is waiting for an IO burst to complete, then the then there is no need for the process to hold the CPU. The CPU can be released so that other processes can take over until the previous process finishes with its IO burst cycle. Right? So operating system encourages the efficient use of CPU by doing this allocation and deallocation. Correct. So similarly, operating system also provides convenient abstractions, which through which we try to isolate application programmers and users from the details of the underlying hardware. So when you are making use of a system, you need not have to know what are its hardwares, or what are the various components involved in it, right? And how exactly they are going to function. So all these care internally is being taken by the operating system. Correct. So just like for example, it is just like we watch a TV. Correct. We watch TV, but we never care of how exactly these colorless radio frequencies are converted into a digital image on the screen. Right? That is a real life colorful pictures on the screen. And similarly, when we are working with spreadsheets, that is the Excel sheets, we never bother about how exactly the calculations are done in the background, right? So we do not know how processing happens, which programs are accessing which machine resources, right? So it is operating system is offering us the abstraction, that is user need not have to understand what exactly is happening inside the system, right? So he can just see the screen, he can just perform his activities without bothering about the internal functioning of the system. Correct. So it is all these are some of the features that an operating system offers us. So similarly, now I want you people to list out what are the various different types of operating systems that are available to us. See, we have Windows operating systems, right? So Satvik says there is a Linux operating system. Yes. Mac operating system, Snehal. Harshita says Ubuntu, DOS, Windows, Sanket. So these are all examples of operating systems, right? I have clearly mentioned Unix is also an operating system. These are all the examples of operating systems. I'm asking you different types of operating systems that you have studied in the previous semester. Clustered systems, desktop systems, are these operating systems? See, I'm talking about different types of operating systems. Have you heard of time sharing operating systems, batch operating systems? Yes. Have you heard of multi user operating systems, multitasking operating systems? Right? So, So there are some uh, so in this screen, in this slide, you can see the various different types of operating systems. The first one is single user, single process operating system, which means that such operating systems allow only one user to make use of the computer system at any point in time, right? So the user becomes the sole owner of the computer system and he can execute and run only one process at a time. So therefore we call it as single user, single process operating system, right? So 25 years ago we had DOS. Now we have Windows and series of Windows operating systems. All are single user, single. Windows 3.1 among the Windows series is a single user, single process operating system, right? So then, so all newer versions of Windows operating system, do you think they are single process operating system, or are they examples of multi-process operating systems? Are you people there? Somebody can speak up. Okay. So then moving on to the next type of operating system, that is the single user multi-process operating system. So such sort of operating systems allow a single user to make use of the computer system entirely, but in this case the user can run multiple processes at the same time. So it is like while you're working on a spreadsheet, you can also work on Word, or you can listen to music, right? And so on. So example is OS2. So then we have multi-user, multi-process operating system. So in this case, the system allows multiple users to log in into it simultaneously, and each user can run his own process at the same time. So what I meant to say is all newer versions of Windows are the examples of multi-user, multi-process operating system, right? So similarly, as Windows and newer versions of Windows are multi-user, multi-process operating systems, Unix is also an example of multi-user, multi-process operating system. So when I say Unix is a multi-process operating system, I mean to say that Unix has a set of processes that run both in background as well as foreground, right? So further in the further lectures, we will be exploring what do we mean by background processes and foreground processes. UNIX architecture, right? So Unix is a giant operating system. So therefore, before we move further, we'll have to understand the Unix architecture and its features. Okay. So looking into the diagram, the innermost circle, you have the hardware, right? So after hardware, you have the kernel, correct? And then after the kernel, you have something called as shell, right? So after the shell, you have the application programs, right? So can anybody define what is a kernel? Yes,
It is file system on hardware.
it is
Means
files. Yes,
it is a program that we can't change. System program.
it's a system program that we can't change. Okay, then anybody else? Yes, Anybody else? Okay. So UNIX architecture comprises of two major components. It is the shell and the kernel, right? So the kernel is responsible for interacting with the machine's hardware, and the shell is responsible for interacting with the users, right? That is the application programs. Okay. So kernel is called as the core of the operating system. That is, it is a collection of routines that are written in C, right? So it is loaded into the memory when the system is booted, and it starts communicating directly with the hardware. So the user programs that need to access the hardware uh, to and use the services of kernel via the use of something called as system calls, right? So the user programs that need to access the hardware and use the that needs to access the hardware, they make use of the services offered by the kernel by making a call by using the system calls, right? So when a system call is made, the kernel performs the job on the behalf of the user. Fine. So the kernel is also responsible for managing the system's memory. It is responsible for scheduling the processes, and it is also making decisions regarding their process priorities, right? So the shell performs the role of the command interpreter, right? So whatever is the command you type in, what exactly should be the processing that is to be performed, and what is to be displayed is the response is all taken care by the shell, right? Even though there is only one kernel running on the system, there could be several shells in action, right? So that is, each user who logs into the system may have his own shell, right? So the shell is responsible for interpreting the meanings of the meta characters, and the meaning of the meta characters that are found in the command line before it dispatches the command to the kernel for the execution. So you can see that in case of Unix, we do not find graphical user these days we find graphical user interfaces, but basically Unix is a command language, right? So you can observe here shell. Here you have a set of commands vid, cut, right? So all these are some commands that can be executed by the shell, right? So then there are various different types of shells that are available to us, right? So the most commonly used shells are brown shell, we have C shells, we have enhanced C shell, right? We have corn shell, and etc. I hope you people have understood what is the job of a kernel and what is the job of the shell. I will repeat, right? So kernel is the core of the operating system. It's basically written you it's a collection of routines which is written in C programming language, right? So it is loaded into the memory as soon as the system is as soon as the system is booted, and it is going to communicate directly with the hardware of the system, right? So the user programs that need access to the hardware, right, they use the services of the kernel via via using the system calls, right? So what are system calls we shall see later in the next slides. Okay, so when system call is made, then the kernel is going to work on the behalf of the user, right? So kernel is responsible for managing system's memory, scheduling the processes, prioritizing the processes, etc. Right? Whereas the role of the shell is like a command interpreter, right? So even though there is a single kernel existing on the machine, there could be multiple shells existing for each user who logs into the machine, right? So it is the responsibility of the shell to interpret the meaning of the command, right? Meaning of the meta characters that are found in the command line and dispatching the command to the kernel for execution. Fine. So then there are various different features of Unix system. So these are so Unix is known as a multi-user system. It is also known as a multitasking system, right? It follows a building block approach, right? And then it has pattern matching, as well as it facilitates the programming, and it also facilitates us with proper documentation, right? So what do we mean by all these things? What do we mean by Unix is a multi-user system? So Unix operating system is designed such that it allows multiple users to concurrently share both the hardware as well as the software of the system, right? So similarly, multitasking system too, when I say it's a multitasking system, it means that Unix allows multiple users to, or allows a user, sorry, multitasking system, it means that the Unix operating system allows the user to run more than one program at a time, right? That is, uh, more than one program can be running in the background while the user is trying to work in the foreground, right? So similarly, Unix offers us the building block approach, right? So are you people there? Are you can you hear me?
Yes.
So can anybody tell me what do you mean by a multi-user multitasking system? Anybody?
Yes, ma'am.
Yes. Can anybody tell me what do you mean by multi-user multitasking system?
Multiple user can log in and multiple tasks can be performed at the same time.
Yes, correct. So the next one is building block approach, right? So the designers never attempted to pack too many features into few tools, right? Instead, what they thought is they shall develop few hundred commands, simple commands which can perform simple jobs, which can perform single simple job, right? So here the commands, here in case of Unix we have small commands, each one performing their own, each one performing a dedicated job, but still Unix supports us to combine multiple commands together, right? So the commands can be connected in a way, uh, wherein we call them to be the filters, because they filter or manipulate the data in different ways. So we shall be making use of pipes and filters in Unix, uh, that help us to combine multiple commands together to form one tool, right? So similarly, Unix also offers us a toolkit. So Unix represents the kernel, but the kernel by itself doesn't do much benefit to the user, right? So in order to properly understand the power of Unix, what we need to do is a host of applications that are shipped to every Unix systems, right? So these applications could have different functionalities, their scopes could be different, but there are general purpose tools, text manipulation utilities, compilers, and interpreters that and the networked applications and the system administration tools which can easily be used here, right? So Unix offers us general purpose tools, text manipulation utilities, compilers, interpreters, and some networked applications, and along with the system administration tools. Similarly, Unix also offers us the pattern matching facility, right? So it offers us a sophisticated set of pattern matching features, right? So uh, so we shall be learning about something called as regular expressions in the coming lectures, wherein these regular expressions would be used to fetch a particular pattern in the given set of meta characters, right? So these regular expressions would be helping us to recognize whether the pattern actually exists or doesn't exist in the given input, right? So Unix shell also is also a programming language. So it is designed by the programmer and not by the end user, right? So as I have already told you that the shell script is written with the help of C routines. So these features are used to design sorry so all these scripts have control structures, have make use of loops, variables, right, and are established using powerful programming language, right? And Unix documentation. So Unix also offers us online documentation, right? So there are various different groups. There are several news groups on Unix where you can file your queries and get to know what exactly it stands for, or you can get your problems solved, right? So these are all the features of Unix operating system. So moving on to the next one, that is how exactly the commands in Unix look like. So commands in Unix have three parameters to it. The first one is the name of the command, followed by the options, and then followed by the arguments, right? So command, you will find a set of commands. As we already know that Unix itself is a command language. Then a Unix command is nothing but a verb that can take a set of options and one or more optional arguments, right? So commands, options, and arguments are to be compulsorily be separated by white spaces or tabs, and see to that the commands are always written using small letters, right? So a contiguous string of space, tab space together are must between the command and the options and the arguments, right? So the options are always preceded by a minus sign to distinguish it from the file names, because the commands can also make use of file names as the arguments, right? So there must not be any white space between minus and the option, right? So it, for example, if my command is ls, then I have an option called as minus L. Then I am supposed to leave a blank space after ls, followed by it. The option starts with minus and maybe, for example, if ls command has an option called as L, then I have to write it as ls followed by a blank space followed by minus L, right? Options are also arguments, but given a special name because they are predetermined, right? So options can normally be combined with only one minus sign, right? That is, you cannot write a command like ls a blank space minus L min sorry you cannot write a command like ls minus l minus a and minus t, right? Because you are not leaving a blank space immediately after the command ls. Fine. So now, yeah, here we have a simple command here. We have written a command called as ls. Ls stands for listing. So after it, compulsorily leave a blank space. And if there exists a option, then option always begins with a minus sign followed by the alphabet that exists in the option list. And if you still have a set of arguments, then again it becomes very necessary to put a blank space followed by the second argument, right? So here, please do not put a blank space between minus and this option character, right? So here I can have I can have multiple options specified in the same line. So for example, if I have a command like minus ls minus l minus a and minus t, then in that case I have multiple options L, A and T. So I can eliminate putting minus each time and I can simply write it as ls minus L, A and T. Are you understanding? So it means that Unix permits me to combine multiple options together, right? Okay. So then, in case, so options, a set of characters involved in options are already predefined. But in case if I give a option that is not predetermined, that is not present in the predetermined list, then the then you get a message saying that the option that you have specified is the illegal one, right? So this is the message given by the command, but whereas it is not the message given by the shell, right? So here you can see ls has ls has almost 20 different options to it, right? All these options shall be explored when we shall be studying the ls command. Okay. Okay. So what I meant to say in the previous slide is if you have a command called as ls and you have an option called as minus a, and in the next line you want to execute a command ls with options minus l and minus h, right? So it is not necessary that you give them separately, but whereas you can simply say ls minus lh, right? So you can combine multiple options together in the command line. Okay. So for today, it's enough. We have seen what is the meaning of an operating system. We have seen various different types of operating systems, right? And we have seen what are the various functions that an operating system can offer us. Along with it, we have seen what is the architecture of Unix operating system, right? And then we have seen various different features of operating systems. Okay. So we shall stop our discussion here. We shall continue in the next class. By the meantime, if you people have any queries, you can leave it behind on the chat box. You can leave it on the chat box. And latecomers, anybody who have joined the meeting at the end may also write their USN numbers on the chat box. I shall consider it as the attendance. Okay, so no queries. We shall start. We shall again meet in the next session. Okay, so I conclude the meeting now. Thank you. You people can leave the meeting.